So example 1 says, determine the following without the use of a calculator. So this is just basic, just a reminder of what we were doing on Wednesday. What we can see here is that we've got a double angle situation going on. If we're not too sure why. No, okay, apparently this is what we're doing here. Okay, cool. Right, if we are not too sure why this is a double angle situation, let's look at our double angle formula with this question. Okay, first thing that I see is that I've got 2 sine 75 cos 75. Because of the fact that those two angles are the same, it means that I have a situation whereby if I were to double an angle, I'm doubling the same value. Remember, we can't work with the double angle formulas if we've got 2 different angles. That would then lean more towards our compound angle formula. Because it's a 2 sine of the same angle, cos of the same angle, we're looking at a sine double angle identity. So what that means is I can now go apply this identity. This is telling me that I'm working with sine of a double angle of 75 degrees. So what I'm doing is I'm taking my formula and I'm applying it to the information I've been given. So that means I'm actually working with sine of 150 degrees. So remember, we spoke about this on Wednesday last week. When you have a situation like this where it asks you to determine the value of something without the use of a calculator, so here, without the use of a calculator, we have to immediately start thinking about our special angles. And as it currently stands, 150 is not a special angle. I don't have a tool to be able to work out the value of sine 150 without a calculator. And so this is now where I need to start thinking of my reduction formula. If I take sine of 180 minus the special angle of 30, I get 150. And this is now where I'm starting to think about those special angles and how to apply them here. Because this is a reduction formula, we can go and apply the appropriate reduction according to what I've got here. This goes back to your cast diagram. Now remember, 180 minus is in quadrant 2, and that's where sine is positive. So this actually reduces to just sine of 30 degrees. Now that is a special angle you can work with. Remember I said to you before, if you don't know your special angles, you can either draw the triangles for yourself at the beginning of your exam on like your answer sheet. I've done those triangles quite a few times, so you should have a screenshot somewhere. Or just use your calculator. Okay, it says without the use of a calculator, but as long as you show all of your working out and you show all your steps, it really doesn't matter. So here, in case I wasn't sure, I would just type that onto my calculator. But sine of 30 degrees is a half. Okay, so just remember your reduction formulae, especially when it says without the use of a calculator and you get an angle that you can't immediately work with as a special angle, just bear in mind your reduction formula and that you can create a special angle for yourself. I'm not changing the meaning of anything here because remember we've spoken about when we did the general solution equations, we spoke about the fact that for any trig equation, there are always 2 identical solutions. And if we have a look at this situation here, we started off with a 150 degree angle, which is, okay, sure, about there-ish. Don't really like that, sorry. So there's my 150 degrees. But where sine is positive, which is quadrant 1, I also have an identical angle of 30 degrees that will give me exactly the same ratio. So remember, there's always 2 solutions, and that's essentially all a reduction formula is, or a reduction is. All right, so take a quick screenshot of that, but now we're going to get into the more in-depth examples of how to now use our double angle formula. Remember, guys, as we go along, if you've got questions, please just ask. This is we sort of did examples like this already on Wednesday. So this is not necessarily a new example, but please do ask questions as we go along if you're feeling a bit lost. Right, but let's have a look at example 2. So example 2 is now sort of starting to get into the types of questions you can definitely expect tests in the coming term, come paper 2 in June, in your mocks, in your finals, etc., etc. Now, if you remember our very first lesson on trig, I said to you that there are 5 different types of questions I can ask you in trig. Simplifying an expression, working with Pythagoras, simplifying an identity, solving an equation, and then problem-solving questions. Problem-solving stuff, like I say, I put in a question or two as we go along just to practice it. But those first 4 are the most important ones we need to know. One of those 4 was simplifying an expression, and this is exactly what we have here. Now, I haven't put an instruction there because this is something I like to do and just leave out my own instructions, but this instruction would say, simplify the following without the use of a calculator. Sometimes they go as far to say simplify or determine the value of, especially when it's numerical examples like this. So in this case, it would say determine the value of without the use of a calculator. And so again, we need to be thinking in special angles. We need to be thinking about the fact that my answer should not have a trig ratio. It should be just a numerical value. Okay, so what we have here is sine 35 times cos 35 divided by tan 225, times cos 200. Now, I said this to you guys before. When you see acute angles, leave them. You can change them later on using your co-ratios if you need to, and you can go and apply compound angles and stuff if you need to. But to start off with, leave them. If you can avoid manipulating acute angles, it just means that your reductions later on are a little bit easier, or it's easier to work with your reductions. And like I say, if you need to change them later on, you can change them later on. There's nothing wrong with that, but leave them for now. I've also said this to you guys before, and I was actually talking to a maths teacher earlier today. Trig is quite literally just algebra. It's literally just manipulation. And so this is what we want to do now. We want to start manipulating this expression to get what we want. Our goal, to determine the value. All right, so to start off with, I'm going to leave my numerator. Those 2 acute angles at this current moment in time, I have got no issue with. And so I'm just going to leave them as they are. If I need to deal with them, I can deal with them. What I do have an issue with is my denominator, because both of those angles are reflex angles, and I can apply reduction formula to them. Okay, so the first one I can work with is tan of 180 plus 45. Now, the reason I'm going straight there is because remember, this would say without the use of a calculator. So I need to once again think of my special angles. If you've forgotten, your special angles are 0 degrees. Obviously, it's not going to work now. 0 degrees, 30 degrees, 60 degrees, 90 degrees. Maybe it would help if I remembered 45 degrees, 60, 90, 180, 270, and 360. Okay, so those are our special angles that we work with. We can get them via formula. Sometimes we're just given them, but those are the special angles that we sort of focus on, particularly these first 4 over here, even more specifically the 30, 45, 60. Okay, but now we've got a special angle in that denominator. It means it's going to simplify nicely for us. We also have cos of 200. Now, unfortunately, there's no way for me to get a special angle here, which is not an ideal situation, but I can get an acute angle, and then I can see if there's a possibility of me trying to manipulate it to something. Okay, so I'm going to apply my reduction of cos 180 plus 20, because that will give me my 200 degrees. Whatever. And now this is all going to simplify to acute angles of sine 35 times cos 35 over, now grade 12s, if you know that tan 45 is equal to 1, you could just write that as 1. You don't have to write the tan 45. Now remember, 180 plus is quadrant 3, cos is negative, so negative cos 20. All right, like I say, tan 45 is 1, so it actually just falls away. And so what we're actually working with here is a sine 35 cos 35 over negative cos 20. Okay, so now we're a bit stuck. Our goal is to try and find the value of this thing, but I'm having a bit of a problem here. Okay, now what I want you guys to think about is the fact that I said earlier, we can use co-ratios if we need to. We can use compound angles if we need to. There's nothing wrong with using that sort of stuff. But we need to think ahead in terms of what is my goal. Okay, so if I were to apply a co-ratio here, remember co-ratio is going to change the name of my trig ratio that I'm working with. So if you're going to use a 90 plus or minus, it's going to change the name of what you're working with and potentially even the sign. Now, there is no point in me using a co-ratio at this current moment. Okay, the reason being is that I don't need to change the name of anything. That's not the issue. My issue is the fact that those angles are not matching up for me to simplify. Now, what I want you to think about is you need to start thinking about the relationships of numbers. One way we could write cos 20 is to say cos of 90 minus 70, because 90 minus 70 is 20. And we could apply a co-ratio idea over here in order to create an angle that suits our needs here. Now, the reason I'm saying it's going to have a look at the relationship between 70 and between the 35 degrees, that's a double angle situation that we have going on. If you were to double 35 degrees, you get the 70 degrees that we have there in the co-ratio or in that manipulation. And so what it means is that once I've applied my co-ratio, I'm able to now start simplifying much easier through the application of my double angle formula. So you guys need to start thinking about what is the best way for me to manipulate my expression to get what I want. And remember, what we're trying to do is we're trying to find a value here. So we're either trying to get those special angles or we're trying to get things to cancel out with each other so that we eventually end up with 1 or a -1 or something. So I can apply the co-ratio here with the idea of getting to a double angle. So I'm going to leave my numerator because, again, even if I applied co-ratios here, it's not going to change anything. All this would end up doing is giving me an angle of 55 degrees, which hasn't solved any problem, and a name change. So now my denominator, I've got minus cos 90 minus 70. 90 minus, there's no sign issue. The name just changes. So I've got sine 35. Obviously, grade 12s, if you can cut down steps as you go along, that's fine. I'm just writing everything down so we understand where everything's come from. Apparently, you can't draw a straight line either. And in my denominator, I now just have negative sine 70 degrees. And because you've seen this relationship with the double angle, I can now use my double angle formula for sine to expand that denominator and thereby simplify. Because remember, what we know is that this double angle of sine 70 expands to 2 sine 35 cos 35. Remember, it was a negative, so it should have a negative coefficient. But hopefully what you now see is that your numerator and your denominator have the same factors, or they match up. So now it's very easy for us to go and simplify. We've got sine 35 cos 35 divided by 2 sine 35 cos 35. What this now allows us to do is it allows us to divide. Cos 35 divided by cos 35 is 1. Sine 35 divided by sine 35 is 1. And so what we end up actually having is negative over 2 as our final simplified expression. Okay, now guys, unfortunately, I can't give you like specific steps. If you do this, this, and this, you're going to get the answer. What is important is that you start to train yourselves or train your brain to see things like double angles, to see things like your co-ratios and your reductions that will lead you to a double angle, will lead you to a compound angle. Because I had that 35 degrees, and because I knew the co-ratio of 90 minus 20 would give me, 90 minus 70 would give me the 20 I started with, I could link that 35 and 70 was a double angle relationship. And so through that manipulation, I was able to get where I want. Like I said earlier, trig is quite literally just manipulation. That is all you are doing in metric trig, is you are manipulating things to get what you want at the end of the day. All right, now, obviously this comes with time. I don't expect you to be able to look at a question like this and be like, oh, okay, cool, this is exactly what I need to do. It comes with practice, it comes with time, and you start with the basic things like leave your acute angles, apply your reduction formula where necessary. Does it make sense to apply a co-ratio? Does the co-ratio allow me to get a double angle formula, a compound angle formula, etc., etc.? So that's sort of the self-talk you need when you're going through your exams. Okay, so take a quick screenshot of this, and then we're going to have a look at a second example of how we deal with a very similar situation, slightly different though, because we're going to have multiple terms now that we're going to look at. And remember, guys, if you've got questions, please just ask. Okay. Lost my mouse. Cool. Right, so if we have a look at example B, sorry, can you see there? See, lost my mind. Would this work if we had cos? Do you mean like a cos double angle situation? If that's the case, yes. Obviously, cos double angles are a little trickier because of the fact that there's 3 options. We are going to have a look as we go along at some cos double angle examples where we need to think carefully about which of the 3 formulae we choose. But yeah, this could work in any context. It would very much depend on what I've given you. So if the question, or if the factors that were given in the question linked back to a cos double angle, then absolutely. There would be nothing wrong with doing that. It's all going to depend on what you're given. And like I say, we will have a look at some cos double angle examples. And then it'll be a case of, like I say, looking at what we've been given and does it link back to that, that formula that we know for the cos double angles. All right. Right, so guys, let's have a look at B. And my question to you as we sort of get into it is, if you think back to like your grade 8 and grade 9 algebra, whenever you are adding or subtracting fractions, what do you need to do? What is the first step you always do when you add or subtract fractions? Nice, can you see there? Right, an LCD. Now, the reason I'm saying that is because if you look at the situation that you've been given here, all of those angles are acute. There isn't really a relationship between double angles because 12 doubled is not 36 and 36 doubled is definitely not 12. We should sort of see that there's a relationship because 12 and 36 are both multiples of 12. So like somewhere in the back of my mind, maybe that's important. But right now, there's nothing I can do with this except find an LCD. Sure, I could apply co-ratios if I wanted to, but it's also not really going to help me. So right now, the only thing I can start by doing is finding an LCD. And again, unfortunately, there's no like specific steps I can give you. It's a case of what do I have? Where can I start? And unfortunately with trig, sometimes it's also a case of you start a whole question and you realize, this is actually not going to work. I have to start again. But if we start with the basics of, as I've been saying the whole time, reductions, co-ratios, etc., we can get there. So right now, because everything's acute, because finding co-ratios or reductions actually isn't going to help me at this specific point, I'm going to start by finding an LCD. Right, so remember your LCD and go back to your algebra. When you've got different denominators going on, you just take each unique denominator and that forms your LCD. So my LCD here is going to be sine 12 times cos 12. What that means is that my first fraction is missing a cos 12. So I'm going to multiply this thing by cos 12. Remember, what you multiply the denominator, you multiply the numerator. and the second fraction is missing a sine 12. So I'm going to multiply that both numerator and denominator. And so what that means I have is sine, let's do that. I need to go here. Sine 36 times cos 12. Obviously, if you wrote those the other way around, it really doesn't matter. Minus cos 36 times sine 12. And this is all over that LCD that we just found of sine 120, sine 12, cos 12. I don't know. It's apparently just not really feeling the whole cos 12 situation. Okay, so if you now look in your numerator, you should start to see that that looks somewhat familiar to you. It's a sine cos, cos sine. That should look familiar to you because it's a compound angle identity. So that's what I said earlier. Even though we have been focusing on double angles at this point, doesn't mean that you can just forget the other stuff that we've learned. So I'm just going to put our compound angle formulas here because I'm not scrolling back and forth and you just don't need to see that chaos. So if we look at our compound angle formula, we've got a sine 36 cos 12 times a cos 36 sine 12. So if we were to write this out in accordance with our compound angles, it would be sine A times cos B minus cos A times sine B. Remember, the angles should match up. And if I go and have a look at where that applies, we can see that that is a sine compound angle identity going on there. Because it's a sine compound angle identity, I can apply that formula. That formula says to me that if we have the expanded form of sine A cos A minus cos A sine A, what we can go and do is we can essentially simplify down to sine of A minus B. So that's exactly what I'm going to do. And the statement I made earlier of 36 and 12 are both multiples of 12 is going to be really handy right now. Because what's going to happen is we're going to have sine of 36 minus 12. And because they're multiples of 12, if you subtract 12 from 36, you end up with 24. And hopefully what we now see is that 24 and 12 definitely have a relationship. It's a double angle. And so now that's the next thought process I can head into. So like I said, this is going to simplify to sine 24 for the sine 12 cos 12. And if we have a look here, this numerator is now a double angle. So sine of 24 degrees, let's try that again, is a double angle. If we double 12, we get 24. And so now we can apply our double angle formula. Double angle formula for sine is a nice easy one. There's only one. So this becomes 2 sine 12 times cos 12 over sine 12 cos 12. And because now we are able to create factors that essentially match up and divide away, this simplifies nicely because the sine 12s divide to 1, the cos 12s divide to 1. And so we're actually just left with 2 over 1, which is 2. Oops. So guys, when it comes to these types of questions, again, it's very much dependent on what you're given. And that's what I said in the answer to Kanyasile's question earlier. It depends on what you're given, okay? I can't say to you that every time you find an LCD or that every time you apply the double angle formula. It depends on what you're given. What is going to be really important for you guys to master these sorts of questions is being able to look at the numbers that you're given and figure out what their relationship is. So like I say, I saw that there were multiples of 12. And already I was thinking, if I have a compound angle where I subtract, I can get a 24. That's a double angle. So you almost need to start thinking of the relationships of the values that you've been given in terms of your angles in order to start working this out. Obviously, like if you don't see it immediately, that is not the end of the world. That is when you start to do things like, can I apply a reduction to a non-acute angle? If you can't do that, do I have fractions where I can find an LCD, etc., etc. So you have tools but you need to start thinking more critically about the relationship of the values that you're working with. Right, let's take a screenshot of this. Oops. And remember, if you've got questions, please just ask. Right, let's have a look at example C. Now, example C might look quite easy, and it looks very similar to the example we started with. But the example we started with was 2 sine 75 cos 75. The situation that we have here is 2 sine 105 cos 255. That's a problem. Those angles are not the same. It's not a double angle, so I can't just go and apply my double angle formula. And this goes back to my very first statement. Trig in grade 12 is about manipulation. You need to be able to manipulate. You have the tools to do that. You just now need to apply them. Now, both of these angles are not acute angles. Okay, both of them are bigger than 90 degrees, which means that your first thought should be reduction formula. So that's what we're going to do. Like I say, sometimes it works, sometimes it doesn't. 99, maybe not be so optimistic, like 90 to 95% of the time, you're on the right track. If you look at this and you think, these are not acute, let me start by using my reduction formula. That's what I'm going to do. Okay. Whew. Might need a talking break. We're going to leave the 2. We've got no issue with that. So we can apply a reduction of 180 minus 75. Now, remember I've said to you before, it's a reduction. It's not a co-ratio. So don't go to 270 or 90 as your first port of call. Go to 180 plus or minus, if you need to, 360. And remember, guys, I've sort of just gone on an assumption here. Whenever you're doing a reduction, so 180 plus or minus or 360 minus, you should always be subtracting an acute angle. You should never be applying a reduction with an obtuse or a reflex angle, because then you're just going to have to apply a reduction again. So it always should be plus or minus an acute angle. With that being said, so I've got 2 sine of 180 minus 75. And what you're going to see here is by applying the cos of 180 plus 75, you're creating a situation where those angles are now the same. Cos diagram, 180 minus is quadrant 2, sine is positive, so this just reduces to 2 sine 75 degrees. Cos, 180 plus, cos is negative there, so this reduces to negative cos 75 degrees. So what we're actually working with is negative 2 sine 75 cos 75. Now this is English. Now this is a double angle formula. Now we've got the 2 sine A times cos A. We can apply the double angle. So this is negative 2 sine of the double angle of 75 degrees. Now we've actually done this all already. So if you want to just go back and copy the rest of the answer, fine. But remember what happened was we ended up with sine of 150, non-acute angle. So we apply a reduction of 180 minus 30. This would also be without a calculator, so I would need a special angle. So I've got negative 2 times sine 30. Sine 30 is a half. So we've got negative 2 times a half, which is actually just negative 1. Also, it would help if I wasn't being so stupid here. Remember, double angle, the 2 falls away. So it's actually just negative half. This is what happens when you talk for too long in your brain. Okay, so I was being dwarfed. Remember, this 2 is part of the double angle, so the 2 falls away. I don't know what I was thinking. So there shouldn't be a 2 coefficient falls away according to your double angle formula. So it's actually just negative a half. And the working out is the same as the first question that we did earlier, because it ended up being the same double angle. Okay, so this one, not a tricky question, but again, because those angles didn't match up, we need to go back to the basics of, apply your reduction. If you need to do a co-ratio, if you need to work with special angles, do all of that. But go back to what you know, go back to the tools that you have. Okay, so let's take a screenshot of this. And then I'm going to stop talking and you're going to try two for me. Right, and remember guys, as you go along, as I'm talking, if you've got questions, please just ask. Okay, so these are the two that you are going to try. So you've got sine 40 cos 40 over sine 100, and then tan 135 plus 2 cos squared 15 as your second question. So you're trying both of them. What I want you guys to remember is that if you're not too sure where to start, apply reductions to angles that are not acute angles. See if you can try and link the values that you're working with double, and then go back to those two. I think you guys should have the double compound angle formula somewhere because we've been doing it a lot now. So let's give those a try. I'm going to give you 5 minutes and then we'll check. If you have questions while you're doing it, please just ask. You can unmute yourself or you can put in the chat. Let's give those a try. Okay, guys, let's have a look. If you're not finished, don't stress. You can just take screenshots and you can mark what you have so far. But let's have a look at what we needed to do here. So for question A, it was very similar to the first example that we did with a similar fraction situation, because it's only one fraction. We obviously can't find an LCD, but we could break down that 100 degrees. So I broke that down according to my reduction, and what I then saw was that I had a double angle. So that sine of 80 degrees could then be expanded to the double angle formulae, and we were then able to simplify further. Okay, so very similar to what we did in the first one. For question B, I will make this smaller for you guys to screenshot in a second. For question B, we had tan 135 plus 2 cos squared 15. So again, apply your reduction formulas to the angle that is not acute. That becomes tan 45, which is 1. So we ended up with just negative 1 there, plus 2 cos squared 15. Now, what you needed to remember is your double angle identity. Let's just do this. So cos of 2a, that's a weird looking 2, I do apologize, is equal to 2 cos squared theta minus 1. So you kind of have that in that situation, but you needed to go and manipulate. You needed to reorganize. So if you just swap those two terms, you ended up with the double angle that you could then go and work with. It then came to a double angle, resulting in an angle of 30, special angle. You can go and apply that. That's what I was saying earlier. You need to start thinking about the numbers that you're given in a more critical way to see, okay, how can I use what I have in order to go and figure out a way to simplify these expressions that I have. All right, let's see if I can get this all in one go. Apparently not. Let's just move this along. Okay, so if you need to take a screenshot of these two, you can do that now. So for that second question, the tan 45 became something I didn't even need to stress about. It was a 15 degrees. And 15 degrees, again, you should automatically be thinking, if I can get that to be a double angle, I can get a 30-degree angle, special angles, apply my special angle formula. The 2 cos squared also should have given you an idea that it was a double angle, because you should have somewhere in the back of your mind, or if you've got your formula sheet in front of you, the knowledge that one of your cos double angle identities contains 2 cos squared theta. And so again, it's all that manipulation that you need to do in order to eventually get there. Right, I hope you've got those screenshots. Let us have a look at another example. Okay, so example 3, and this is now going back to one of those types of questions that I said we need to be able to know for our exams, which says prove the following identity. Now we are going to do a whole lesson on identities, but like I say, it's important to start understanding that this can now be applied to all those different types of questions we've spoken about. So it says prove the following identity. Sine 2 theta times tan theta divided by cos 2 theta plus 1 is equal to tan squared theta. All right, so there's a fair amount going on. If you remember back to our first lesson, I said to you, when we're proving an identity, firstly, you only work with one side of the identity. Your goal is to prove that the left is equal to the right. So we do not work with this as an equation, because if you work with it as an equation, you are assuming it's already equal. We pick one side to work with, that's the side we work with. So that's the first thing. The second thing, in determining which side you want to pick, is you pick the side that's more complicated. So you pick the side where you can see that there's a tan, where you see that there's maybe a reduction going on, where you see that there's a double angle going on. You pick the side where there is more room to do the manipulation, because again, triggers manipulation. Now, in this case, you've got tan on both sides. But if you look at the left-hand side, there is not only a tan, but there are also double angles. There's a sine double angle and there's a cos double angle. And because there's more that we can manipulate on the left-hand side, that's the side that we're going to start with. Okay. So my left-hand side is the sine 2 theta times tan theta over cos 2 theta plus 1. Okay. Now this goes back to, and sort of links to Panicelia's question earlier of, I've got a cos double angle. There are 3 formula that I can use. How on earth am I going to pick which one I want to use? Okay, let's just grab our double angle formula for ourselves. Okay. There are my double angles. That's essentially what I'm going to use here. The first thing that you always do once you pick your side is you change your tan. Okay, now because sine as a double angle only has one option, we can actually change the sine double angle as well. So the sine double angle is 2 sine theta times cos theta. Remember, it was a double angle. It was 2 theta. When you expand it, it becomes half. So it's just now theta. And tan becomes sine theta divided by cos theta. That goes back to the tan identity that we've spoken about before. And what I want you guys to remember is that the tan identity can apply to whether it's squared, whether it's a double angle. So this could be a tan squared theta equals sine squared theta over cos squared theta. It could apply to a double angle. So tan 2 theta equals sine 2 theta over cos 2 theta. Essentially what you need to just see is that the sine, the cos, and the tan are all identical with their angle and what's happening to them. That all is the tan identity or variations of it. All right, so that's just in my numerator. I'm going to leave my denominator for now because we're going to have a discussion about which cos identity we use. Right, now my numerator can be simplified because what you have going on here is a multiplication of a fraction. And so the cos thetas actually cancel. When you go and multiply that, you've got 1 cos in the numerator, 1 cos in the denominator. They divide away, they're gone. And so all you actually have here is 2 sine squared theta, because sine times sine is sine squared, over cos 2, not cos squared, cos 2 theta plus 1. Now, the reason I left that denominator is so that we can now have a conversation about which cos double angle to apply here. And it's going to go back to what I've just said about the tan identities. Okay, these are my cos double angles. Hello? Okay, those are my cos double angles. I also just said to you that if you've got tan squared theta, you can write that as sine squared over cos squared. Now remember, our ultimate goal is to end up with tan squared theta. Tan squared theta can be written as sine squared theta over cos squared theta. If you look at what you currently have, you've got a sine squared theta in your numerator. So that would mean in order for me to eventually end up with tan squared theta, I'm going to have a cos squared in my denominator somewhere. That's the only way I can get a sine squared in my numerator and the cos squared in my denominator to become a tan squared. So I'm going to have to pick the identity that contains a cos squared. Now I've got 2 choices. I've got a cos squared minus sine squared, or I've got the 2 cos squared A minus 1. Now remember, if you introduce the sine squared, you now have to deal with the sine squared. So I kind of want to pick this one because that's the one that only has a cos squared. Yes, it's got the minus 1, but look at your denominator. You've got a plus 1. Plus 1 minus 1 is 0. It's actually going to cancel away. So this is what I was saying earlier when you now need to start thinking critically about what information you have and what you can now apply in terms of your formulas that you know. So that cos double angle, I'm now going to change to 2 cos squared theta minus 1, and then remember I still have the plus 1. Now minus 1 plus 1 go away. Okay, so those are gone. Don't need to stress about it anymore. This now leaves me with 2 sine squared theta over 2 cos squared theta. The 2's divide away. Sine squared divided by cos squared, I just said is tan squared theta. You have just proven that this identity is true and that your left-hand side is equal to your right-hand side. Okay, so when it comes to these sorts of identity questions, I just want to make this a touch smaller so that you can screenshot it. When it comes to these sorts of identity questions, again, start with the easy things that you know you can do. Changing a tan. If there is a reduction, we could apply a reduction. In the case of the sine double angle, there's only one formula, change it. When proving an identity, you always need to be looking back at what you're trying to prove. So that's why I took a little moment and I thought about my tan identity. And I said, okay, well, I know I have to end up with tan squared. What does that mean I need? It meant that I needed a sine squared over a cos squared. And if you kind of know what your next step should be, or if you know what your final result should be, you know what manipulation you need to start doing. You know what you need in order to get where you want to be. Proving identities is by no means an easy thing, because again, I can't just say to you, do step 1, 2, 3, 4, you've proven the identity. It's not how it works. But we need to remember that we have all of these tools available to us in order to go and prove that identity. Okay, we're going to do lots more like this.